Welcome to season 2 of Practical AI. My name's Jeff. I'm with Peter Lin. We are sponsored today by Pocket AI. Pocket AI is a tool used to perform surgery on your models to make them better. While everyone today is talking RAG and refinement, Pocket AI allows you to edit the weights of your model directly. Peter, training your own model is not easy to do, and so we wanted to do a series here, and we'll call this episode 1 of training your own model, right? Lessons
Yeah.
learned, best practices, however you want to look at it. And today's episode, you thought would be good to start with the data science space and essentially the challenges that data scientists have in training their own models.
Yeah.
Lay out kind of the struggle and kind of what your experience is here.
Well, so historically, the biggest challenge with data science is one is figuring out what data you need. So that's the biggest one. And then two is getting the data that you need. Three, measuring whether or not that actually is the data that you need to train with. So just those three alone makes it really hard because today there are no great tools for this.
So
If you're
what data
training,
do you need? Getting the
yep,
data. And then what was the
yep.
third one?
The third one is the data that you got actually good data?
Okay. So
Right. So if you
quality,
go back
essentially.
to some of our early conversations about like training computer vision, if you're an apple grower and you grow 10 varieties of apples, right? So now you got to decide, okay, do I take pictures of the apples right when they're starting or when they're ripe? Or do you take pictures as it's maturing from the small little bud, from the flower, all the way up to a fully ripened apple, right? Like that's an important decision because it'll affect how well your model works. And so that's the first thing is like, what data do you need? And then
Yeah.
two, you gotta go out and take it. Well, that sounds simple, but let's say a farmer goes out to the field and takes pictures. Well, is the lighting correct? Is it cloudy that day? Is it too bright? Is your exposure correct? Are you using a DSLR camera or a mobile phone or a tablet? Like all these little things matter. Then there's once you've taken it, do you use the full resolution of the picture? So if you've got a Samsung phone or iPhone, and it's 20 megapixels, you probably don't need the full 20 megapixels. And so now it's like, okay, well, you gotta downsample it to something more usable and reliable. You probably only need maybe 300 by 300 pixels. You probably don't need more than that, but you might. So again, it that comes down to like once you've taken the pictures and you've downsampled it, did you do that correctly? Because if you're trying to make an app that can diagnose diseases for apple and apple trees, well, you probably want more resolution than if you're just trying to categorize a red delicious versus a golden versus a Macintosh.
Got it. So you got to kind of know ahead of time. Now, let's say I started with just wanting to know the difference between apples, right? And then I wanted to extend it. I don't want to use the word refine, but I wanted to extend the model to do more. And let's say I did want to do something like spot recognize existing diseases. So now I'm going from recognizing varieties of apples to recognizing diseases of apples.
Yeah.
Can I use the model that I built as sort of a chassis to do more? Or is like, and let's say to your point, I need way more high quality,
Yeah.
images. So I need to go from 300 to, whatever.
Right.
Do I have to start over? Or is it kind of unknown? Depends.
Well, so that's a really a case by case thing. So let's say I start out and I go, well, I only need 100 by 100 pixels to tell between Granny Smith, Golden Delicious, Red Delicious, Macintosh. All right.
Honeycrisp,
So you do that.
my favorite.
And so you train the model, you spend a couple months and you train it and it gets decent, gets let's say 90%. Well, so now, and it's working and it's acceptable. But if you think about diseases, just knowing the rough, you know, hue and color and shape of an apple isn't going to be enough to tell the disease. So you couldn't take that one and improve it to be able to use to detect diseases now. So now, and even then, the way you've cropped the image, right? So maybe when you took the photos originally, you took on a phone and they're 20 megapixels and you cropped it down to just as small as you can around the apple itself, without leaves, without the branches, and just to make it easier for the model to train. Well, now, if you're trying to detect the diseases, you might want to take pictures with the leaves around the fruit. And so now that image is actually quite different. And so not only is it bigger, it's got to have more details, it's got to be higher resolution, and you probably need a different model. And so at that point, no, you can't use the original one. You have to build a new one.
Okay, so the data scientist, maybe we should define that term a little bit, right? I mean, because I'm thinking that it probably had like a lot of words around machine learning and IT in general. It probably has a couple different meanings depending on who you talk to. Um, what's an acceptable sort of definition or role of a data scientist, and what isn't a data scientist?
Right. So that definition has changed over time. If you go back, let's say 10 years, a data scientist was really just, they knew some TensorFlow, they knew how to like basically use the machine learning frameworks, but generally they didn't have a CS degree. Generally, they weren't hardcore into like programming. They weren't like hardcore database programmers or C++ or Java or C# programmers. So they were just writing in Python primarily, and they were thinking about data. So a lot of what they did was taking data, trying to look for patterns or samples, but that's evolved over time. So now in the ML space, a data scientist is someone that is supposed to define what data you need to build the data set for training.
Okay, so they kind of bleed into the governance layer a little bit and quality and okay. Okay, so now let's turn this into something that's sort of lessons learned. Okay, so now you've done this enough. What do you what do you recommend to people in this space? Why do data scientists hate machine learning training? But how do we learn something from all that pain that people have gone through? And what do you recommend people do that maybe they don't think to do?
Well, it's today, the sad reality is the tools available to data scientists is really limited because basically they're just using Python, most of them, and maybe they've written some tools to do like reporting, which is all good, and that's kind of the foundation. But in terms of actually training, very few people, there are very few tools. Actually, there's no tools for you to dive deep into what did the training look like for the training data. Like if you look at weights and biases, you look at TensorBoard from Google, which is the visualization part of the TensorFlow, all they show you is the accuracy and the loss. And that's it. They just go epoch one, here's what it was. Epoch two, that's what it was.
Yeah.
But that's not enough granularity for you to understand, like, oh, this is why my data is good or bad. This is where my data needs to be modified or improved. Or this is where my data is bad and it's causing my training to just go haywire.
So when you designed Pocket AI, you had this in mind. And so what did you add or what did you include that would make the life of the data scientist a little easier?
Well, so I wasn't thinking about data science, I was thinking about myself. So it wasn't really for anyone else when I started doing it. I really wanted to see like, okay, as it trained, what was the accuracy and loss for each actual class?
Hmm.
Because then I could then look for patterns of, okay, if classes 1 through 4 were really good halfway through and was excellent at the end, was there a trade-off, right? So like maybe the classes 6 through 10 were terrible because 1 through 4 just the model kept going, okay, 1 through 4, let's get really good at that. But then like 6 through 10, it was just like, oh, okay, it's just complete garbage. But with regular accuracy and loss, you can't see that. It's like because to the model, it's just like the overall performance for everything. And it's okay, right. That matters. But as a data scientist and as a machine learning engineer, that doesn't help you improve your data.
So the data scientist using Pocket AI can determine by class
Yep.
accuracy and loss, and then even by image, right? You could go into each individual input and make a determination, correct?
Yeah, and actually there are no tools today to do that. Like if you were training a computer vision model, there really are no tools today that you could say, all right, I've trained it for 1,000 epochs. I want to know which epochs was correct for a red delicious apple. Like there are no tools for that. You'd have to write your own.
So one thing a data scientist could do is use a tool where they can get at the class and then even at the individual input level.
Right. Yep. Yeah. And
They could find
even
it.
in the literature, no one really writes about this.
Solve it with volume, more data, bigger model.
Right. And that's understandable because, if you're training a model and you've got 10 million images, as a data scientist, do you have time to go through 10 million images?
That's
Like,
a
no.
lifetime. Right.
Like, how many hours in a day are you going to spend? And then how many can you go through? Right? It's just not practical.
Well, and that's if I understand correctly, you built into Pocket AI the ability to just recognize the patterns, and so you don't have to go to the millions of individual records or classes even for that matter. You can boil it down a little bit.
Right. Yeah. So the easy hack is you can calculate how well it generalized for each piece of data. And so you just go, okay, across the training run, which ones were correct and which ones were not. And I just calculate the average. So I call it the generalization score so that we know for this image, that's what it was. And then we can easily filter like, okay, give me all the ones that were between 0.3 and 0.4. And then once you've got that, it's a much smaller subset. And then we can actually compare the actual accuracy for all the epochs that you care about. And then you can look, okay, let's look at epochs, let's say 100 to 400. And then you can actually boil it down and go, okay, here are the ones that are similar. And you don't have to manually sit there and be like, okay.
10 million records.
Yeah.
This is great. Sounds like we've got some other conversations to have, including accuracy and loss, generalization scores, and many other things. So this is good. This is a good start. We'll stop here and we'll pick this conversation up later in terms of training your own models, lessons learned. Thanks, Peter.